Hi everyone, this is Rick Balkin and I'm going to show you how to run a one-way Anova using JASP. So from here, let me share my screen with you. And I'm going to open up JASP. And I'm going to open up a data set here. This is a data set that I made up. It shows my dependent variable is anxiety, and my independent variable is political affiliation or political stance. And you can see if I go here, I have liberal, very liberal, conservative, and very conservative as my political affiliations, and then anxiety of the current administration. At the time of this tutorial, Donald Trump is the president. So we'll see how these groups rate themselves on anxiety. This is a very small data set. It is made up. I'm just making this up, but you can see that there's only 20 participants. You probably wouldn't run a one-way Anova for 20 participants, but this is a tutorial. It's a heuristic example, so let's just go with it. So the first thing I want to do is I want to test my model assumptions. In order to run a one-way Anova, there's rules. We have independence, normality, and homogeneity of variance. I want to make sure that each individual for independence is in one group and only one group and in no other group, and that's the case here. I would learn about that in my methods. But now I want to check the normality assumption. So I'm going to go to descriptive statistics, and there's certain things I can do here. Number one, I can put anxiety in my variable column and group in my split column. And so it'll look at every, you can see, oh, I've got 5 in each group. Here are the means and standard deviations and minimum and maximum values of each group. I could ask for plots. I probably wouldn't want to do this with such a small data set, but if I had a larger data set, I would definitely want to look at box plots or QQ plots. I could certainly do that. And you can see JASP provides all of this information. But that's not how I'm going to evaluate normality with such a small group. With a small group, I'm going to click on statistics and scroll down here, and I'm going to click the Shapiro-Wilk test. And that's going to add information to my descriptive statistics. And it's going to show me that none of these groups are statistically significantly deviating from a normal distribution. I can even look at the skewness and kurtosis of each group if I want to produce those numbers and see where we're at. And you can see that, for skewness, they're all pretty normally distributed within, this is slightly one standard deviation here above, above what's considered normal at 0. So I can also get other values as well, the interquartile range. If I wanted that for each distribution, I can look at quartiles. So a lot of information I could get here. But I'm going to look at the Shapiro-Wilk statistic here, and I'm going to say nothing is less than 0.05. So I've met the assumption for normality. So let's run my Anova. From here, I go to Anova, and I click the option, and I put in my dependent variable, which is anxiety score, and I put in my independent variable, which is group political affiliation. And I'm going to run the homogeneity test. And you can see JASP has already produced the results here. I have a statistically significant effect. I've met my homogeneity of variance assumption. P is greater than 0.05. Had I not met that, I could have clicked on homogeneity corrections and chosen a Brown-Forsyth or a Welch's F. But so far, so good. Everything looks good. So I have a statistically significant finding. I haven't gotten an effect size, and I want that. So I go to additional options, and I scroll down, and I click on effect size. And if I want a descriptive statistics table in APA style, I can ask for that as well. And there's my means and standard deviation and sample size and APA style here. And then here's my eta squared. The amount of variance I'm accounting for from the independent variable is 68% of the variance is accounted for group affiliation accounts for in anxiety. And then finally, I might want to run some post hoc tests. And so I click on post hoc, and I'm running a post hoc test for group. And I like to run a Tukey. And I also want to produce maybe confidence intervals, and effect size. And I'm just going to move this over here. You can see what I've clicked, and you can see my p-values for my Tukey post hoc analysis. You can see my Cohen's D's, and so you can see, wow, there's a really large effect, but it's not statistically significant, so we don't have enough power here. Here we can see a very large effect of 4.5 standard deviation unit difference between very liberal and very conservative. And that was statistically significant. And between conservative and very conservative, Cohen's D of 2.8. So, and you can also see the confidence intervals for effect size, which kind of tells you, at 95% where are these going to fall. So, one of the problems that you have here, say, between liberal and very liberal is that, why isn't it statistically significant? Because your effect size is going to fall anywhere between a very large difference and a small difference. And so that's telling you nothing. Whereas you can see here, all the differences are large, when they're significant. So that's my analysis using JASP. And you can see I get all the information: statistical significance, effect size, confidence intervals. I've checked my assumptions to make sure I'm following my rules. And so now I'm ready to write my results. So thank you for looking in on this.